curves.
Happy to. Speaking of curves, you don't want a curve.
Yeah.
I don't think you know what a curve actually is.
No, I'm saying the curve has to 100.
I don't think you know what a curve actually
No, don't
is.
do the math or anything.
That's not a curve.
Just put it to 100.
That's not a curve.
Round up to the nearest 100.
Yeah, just round up to the nearest 100.
A curve is fitting into a bell curve, which means the higher end loses points, the lower end gains points, and the ones in the middle don't change.
Round up to the nearest.
I did statistics, yes.
Or round up to the nearest.
That is a
You're
true
right.
curve. I've done that before,
Let's do it now.
where they begged me for a curve, so I curved it, and they regretted it.
Checks out.
Yeah, it sounds about right.
My teacher didn't really do grades. He just adds some points in.
Yeah, it's not a curve.
So mental note, don't ask any math teacher to do a curve.
Don't ask them for help either.
We are now 2/3 of the way through, and I think we had a few more casualties.
What?
What?
Fewer people are here right now.
Yeah,
so
I think we had a
gotta
few
wait
more
until here.
casualties.
Wait, actually?
There are fewer people in class right now.
Yeah, but maybe they missed out.
Might be.
We're late.
That's why I said I think, or it appears. We'll find out. So that's the good news, right? 2/3 of the way through. The bad news is it's all uphill. Because this third exam is going to be the hardest exam in the semester, material-wise. We have to finish triple integration. That's what we're doing tonight. Then it's vector fields, kind of bringing all of calculus together. The whole point of the calculus sequence is to get to the three theorems: Green's theorem, divergence theorem, and Stokes theorem. That is the whole purpose of the calculus sequence. Calc 1 was the fundamental theorem of calculus, right? Calc 2 really had no purpose. It's that middle child that no one cares about. And then Calc 3 is the oldest child that everyone loves, because it's the main purpose.
I'm the oldest. I don't remember
I don't
when I
know
was
about the
alone.
love part.
Firstborn is always the favorite.
No, it was not.
No, littlest is always the favorite.
No, firstborn is always the favorite.
No, littlest.
As the oldest, I can definitely tell you I am not the favorite.
I just put oldest in
Firstborn
every
also
sibling.
also has all the hopes.
The oldest gets all the perks, but the one that's loved the most is the littlest one. That's how it is.
The first one is basically the giraffe child.
So we look at my favorite theorem again. Fubini's theorem, but now in cylindrical coordinates. So we have a continuous function, g of x, y, z, on a portion of a circular cylinder, which described is given a less than equal to r, less than equal to b, alpha less than equal to theta, less than equal to beta, c less than equal to z, less than or equal to d. Then g of x, y, z is g of r cosine theta, r sine theta, z, right? Remember your conversions in cylindrical coordinates. Define that as some function of r theta z. The triple integral over b of g dv, the integral from c to d, integral alpha to beta, integral a to b, f of r theta z, r dr d theta dz. Typically, that's not the order it's written in. It's generally written in the order dz, dr, d theta. But again, the order doesn't matter. Notice your dv is not dr, d theta, dz, just like with polar. It's r dr, d theta, dz. So what's the most common mistake? That r. Do not forget that r. And remember, cylindrical is identical to polar, except now you have a height. And that height coordinate doesn't change, it's just z, it stays. So that's not too terrible. That's boring. Now for my favorite favorite form of Fubini. His final form, if you will. Spherical. Way more useful. Now we have a continuous function on a portion. Just in time. You're going to love this.
Oh, yeah.
Especially if you study E&M. Continuous on a portion of a sphere. Described A less than equal to rho less than equal to B. Alpha less than equal to theta less than equal to beta. Gamma less than equal to phi less than equal to psi. Remember your conversions? G of x, y, z, g of rho cosine theta sine phi, rho sine theta sine phi, rho cosine phi, call that f of rho theta phi. Then the triple integral of GVV, integral alpha to beta, integral gamma to psi, integral a to b, f rho squared sine phi d rho d phi d theta. That is the typical order. I think I just forgot to change it to the standard order for cylindrical. Notice what your dv converts to. You get an extra rho squared sine phi. Do not forget that. Most common mistake is that's forgotten. Second most common mistake is you write rho sine phi instead of rho squared. I've also seen just sine phi or just rho squared.
What's the name of the Greek letter that looks like a Y?
Which one?
For phi, the lower bound.
Lower bound, that's gamma.
Gamma, thank you.
Third letter of the Greek alphabet.
What's the upper bound of that?
This one?
Yeah, the one with the upper bound.
You call yourself a physics major, you don't know that one?
No.
That's from quantum mechanics. That's psi.
Psi, got it.
My favorite Greek letter. Heisenberg's equation. Oh, I forget. You can't actually see my mouse cursor on the screen. You can if you do this. That's I. Describing a region cylindrical, not terribly difficult. Describing the region in spherical coordinates can actually be really difficult. I think of the one quiz question that I just wrote. That's fun. That was a fun problem. Really enjoyed it. We're going to see who knows their stuff on that one. Also, deciding which one to use. Cylindrical and spherical can be challenging. Some regions best described in cylindrical. even if it involves a sphere. Other regions best described in spherical, even if it involves a cylinder. But then you have some that are just completely obvious, like this one. So we're going to evaluate this iterated integral. Now bear in mind, in rectangular, that's not possible. So we have to convert this. Question, which one do you want to convert to?
I think it's cylinder. Wait. Yeah, cylinder.
Cylindrical?
Absolutely, yeah, cylindrical.
Who wants to play devil's advocate?
Spherical may work better.
Okay, we have spherical.
Yeah.
Excellent.
Because of the square root of x squared plus y.
Who thinks we should do show of hands? Spherical. Spherical? You're changing?
I'm not a scientist. I'm not going to argue.
This is clearly a portion of a sphere. Which portion? So, is it a hemisphere? Yes. Which hemisphere is it?
The top.
No. You're getting there. I can see the way you're doing it. The front hemisphere.
Okay.
Right. Notice what your last differential is, x. X is positive, which is the front portion. Right, so you have 6 hemispheres: front, back, left, right, top, bottom. This is the front hemisphere. First, describe this. How do we want to start? With rho? What are the bounds for rho? How would you describe rho?
Zero to 7.
0 to 7. Remember, rho represents radius. What about theta?
Is it 0 to 2 pi or 0 to pi? I think it's 0 to pi.
0 to pi?
Yeah. Isn't it?
Negative pi on 2 to pi on 2.
Why?
Oh, because
Because-
it's the front.
Yeah, the front kind of.
Your x is positive, your y can be both positive and negative. Right? So if you just restrict it, because remember theta is dealing with the xy plane, that's quadrants 1 and 4. So there's actually 2 ways you could write it. If you stick with the convention of theta being between 0 and 2 pi, you actually have 2 regions. 0 to pi over 2, and then 3 pi over 2 to 2 pi. This is where I then break with convention and use the minus pi over 2 to pi over 2, because I don't feel like doing 2 regions. I feel like doing 1 region.
So the y-axis comes out to you. The
X-axis.
goes- Oh,
X-axis is, so the x-axis, in math, standard x is depth, y is length,
and then z.
and z is height. Another common one is x being length, right? So you do the standard xy and then you let the z be the depth. That's also fairly common. But as long as it follows the right-hand rule, it doesn't matter how you do it. Nope. Why do I write 0 to 2 pi?
You get in your head, huh?
And what about phi?
Negative pound 2, pound 2.
The 0 to pi,
It's 0 to pi.
it comes off of the positive z axis, right? Okay.
It's remember, phi is the angle of declination from the z-axis.
Z's going up and down.
It really doesn't matter how you draw it. Phi is always measured from the z-axis. So if you think of it as up and down, that's why we call it declination.
Yeah.
And since z can be both positive and negative, it's the whole thing, 0 to pi.
All right.
And generally speaking, you're never going to write phi as something like minus pi over 2 to pi over 2. It's always going to be some subset of 0 to pi.
Okay.
Theta is the only one that we really just change. Just so I don't have to rewrite it, I'm going to call that I. Convert your integrand into spherical. What is it? dy dz dx is going to become rho squared sine of phi, d rho, d phi, d theta. Simplify that. I'm not going to do 2 steps at once because there's also no theta. So what's the length of the theta interval? And remember, order doesn't matter. That's why I can integrate with respect to theta first. Does it matter if we integrate rho or phi first? No, right? Rho doesn't depend on phi, and phi doesn't depend on rho. So we can do either one first. Rho is probably easier. Integral from 0 to 7 of rho is what? 49 halves. Now, the integral from 0 to pi of sine of phi.
Positive 49 pi.
I'm just looking for the integral of sine of phi. From 0 to pi. Ignore the 49 pi over 2 for now.
Negative cosine.
Negative cosine from 0 to pi, which is what?
Negative 2.
Positive 2.
Uh,
No, because it's negative cosine.
oh,
So
right.
it'd be negative at
Right.
negative 2,
Right.
which is positive 2.
Yes.
So that integral is 49 pi. That's something that's probably going to come up a lot. So maybe keep this in mind. so you don't have to keep doing that work. Okay, so that wasn't too bad.
Uh, if you don't mind, quick question about polar. Just as r squared equals x squared plus y squared, rho squared equals x squared plus y squared plus z
Yeah,
squared.
rho,
Okay.
rho is a radius.
Yes.
So
yes,
distance from the origin to the point.
yes. Thank you.
No more nice guy. So we want to evaluate the integral of the square root of x squared plus y squared over the solid bounded by the circular paraboloid z equals 1 minus x squared minus y squared and the xy plane. So it was what? The paraboloid and what is the xy plane? How would you represent that?
Z equals 0.
Start with a standard viewing box. And then go from there. Turn off the mesh. No, it's just the way to stop. That is actually annoying, but okay. Okay, that's definitely not as large as I wanted it. It's bigger than I was expecting. That's better. So which one do we take?
do cylindrical?
Well, I'm just saying for the region. What do you take?
What do you mean?
There are two regions that could fit that description.
Oh, the one above the XY plane,
Why?
because that's our bounds. Has to be above the XY plane.
Does it?
It says so in the problem, I'm pretty sure, yeah.
You would let the ones go on infinitely, you can put them underneath. That's why, we would just go on infinitely, so it would have to take it, you know, this for it to be bounded.
So we set it down, so it has to be.
So it has to be between them, it can't be, like, going on forever.
This is going to be the top.
Yeah.
Even though you can actually have an improper multiple integral, it could be the bottom.
It would just go on there.
You would then have an infinite interval,
Yeah.
which is allowed. We don't cover it, but it is allowed.
Well, like, what would be the answer to that, like, hypothetically?
You'd have to evaluate like you would improper integrals from calculus. Yeah, we're going to ignore those possibilities. You won't in physics.
That means it's always for a little bit.
Just wait till you get a triple integral where all three bounds are minus infinity and positive infinity. Right, so yeah, we're going to take that upper portion. So then it then boils down to which system do you want to use?
I say cylindrical.
Why?
It's very easy to convert everything, and all the math makes a lot of sense.
Yeah, this one is clearly a cylindrical problem. You could do spherical. You are allowed to do spherical.
Would be fun.
Mathematically.
These are just,
Have fun. Is that a good view? Maybe I want to do something more like that. Yeah, that would work better, I think. Yeah, that looks good. R.
Zero to one.
Theta.
Zero to two pi.
Z.
0 to 1 minus x squared plus
Oh dear.
1 minus x squared minus 5
Oh
squared.
dear.
R squared.
These should be the same.
Wrong coordinate system.
Oh, you're right.
I generally am.
0 to 1.
R squared.
Just don't tell my wife that because she's never right. Although, we'll say she is actually good at admitting when I am right. I can always tell when I won an argument because she shuts up, walks away. And then she'll admit later that I was right.
When you've won.
So that was half of the battle. Well, I guess half of the hard battle. Right, we're describing the region. Now we have to set up the integral. Do I want to do that on this slide? No. What was that, right? X squared plus y squared dv. Yes. What order are we going to use? Because there's what, 6? There's 6 orders you can use.
Well, we want Z to either be first or second on the inside. I would try Z innermost.
Okay.
First, and then R and theta after that, from inside to outside.
Not work, it's the standard order.
Okay.
Order doesn't matter, except that Z has to be done before R. Because Z depends on R. The only restriction we have on the order. Now write the integral. You know what? I'm going to move that down just so we can see the upper limits better. Write the integrand in cylindrical.
R squared dz dr d theta.
You skipped a step. I just want the integrand.
R.
Now write out dv. Stick with that intermediate step until we get the hang of it. Otherwise, you tend to forget. You might tend to forget that extra R there. So again, I'm going to do 2 steps at once. Is there a theta? So I'm going to integrate with respect to theta first. What do you get? What was it? I'm deaf, I'm an old man, I can't hear. Oh, actually, do 3 steps at once. There's no z either. What's the integral with respect to z? I'm blind as well.
1 minus R squared.
Helen Keller, mathematician form. And physician, and physicist. Those are different things.
I don't need to hear or see to be able to understand the universe. I just need mathematical formulas.
It was almost spiritual until you brought it back.
I can do that all in my head.
What are you going to do?
That's what we're left with, right? Oh, look how easy that was. If only they were all like that. So again, the hardest part was getting to the setup, right? Evaluating it was no problem at all. What is that integral? So integrate r squared minus r to the fourth from 0 to 1. What do you get?
Third minus the fifth.
What is a third minus a fifth?
2/15.
And there's your integral, 4 pi over 15. So we're going to integrate x squared plus y squared plus z squared over the ball of radius 2. Get used to that notation. You see it a lot in physics. I think they use like b sub n for ball of radius n. What coordinate system do you want to use?
Spherical.
Spherical? So describe it in spherical coordinates. Set of ordered triples rho theta phi such that what?
P goes from 0 to 2, theta goes from 0 to 2 pi, phi goes from 0 to pi.
How many points was it every time you said p?
Did I say P? Darn it, I was so close.
I think it was 10, wasn't it?
I think it
I thought it
was.
was
So that's the second or third time. I'm going to say third.
All right, we'll go with that.
So you've lost 30 points so far this semester.
We'll work with that.
Oh, that was an easy one to describe. What order do you want to use? Doesn't even matter. So stick with the standard order. Integrand in spherical is what?
Rho squared.
And now dv is what?
Rho sine phi.
Finish it.
D rho, D phi, D theta.
Rho squared. Sine.
What did I say at the very beginning of the class? What was the second was common
The
mistake?
anagram is rho squared sine.
Very common to do, so don't feel bad. But that's why I write it out. Oh, well, there's no thetas, right? When you integrate with respect to theta, what do you get?
2 pi.
Oh, look, there's also an integral from 0 to pi of sine and phi. What do we say that is?
0 to phi.
0 to pi of sine and phi is what?
Oh, it was 2.
So right away we can just pull out a 4 pi. Be left with this. What is the integral of rho to the 4th from 0 to 2?
One-fifth row to the fifth, evaluated from 0 to 2.
Which is what?
32 over 5.
32 fifths. Multiply that by 4. What do you get?
128.
So 128 pi over 5. And now I want red lobster.
There should be like 60, 70. But they went bankrupt.
And the best biscuits.
Why red lobster?
See the shirt.
I was like, what is there?
I give you permission to throw something at him.
No,
You now
I
crave red
can't.
lobster.
I can't. I won't stop anybody, but I can't. Those biscuits.
Like I've never
Can make a meal just out of
seen
those.
anyone go to Red Lobster past like 2015.
I would go. I would literally go just for the biscuits. I could care less about the actual lobster.
Maybe that's my YouTube.
I'd go in there and just order like 8 dozen cheddar biscuits and take them home and make myself a real lobster.
If you're gonna go to a restaurant just to get their bread, you should go to Texas Roadhouse.
Yeah.
And
You know,
that's
they
what
had
I do want.
Texas Roadhouse bread. Yeah, definitely.
They got the best bread.
Yeah, that's solid. I mean, Cheesecake Factory bread's pretty good too, but they have nothing with Texas Roadhouse.
Where did I go where they served you with cinnamon butter? Because that was the best.
Texas
Wasn't really the,
That's
it wasn't really the bed, but
That's
the
Texas
butter
Roadhouse.
was. Oh,
Yeah,
for
it's
free.
the bread with
Yeah.
cinnamon.
Like you didn't have to order that. Like
No, it came with
it
the.
comes like they
Whoa.
just bring it down like whenever. You just run. I just ask for more.
I forget where I went to get that.
It's Texas Roadhouse.
It wasn't Texas Roadhouse that I
Sure.
went.
They do have also the.
It wasn't Texas. I've never been to Texas Roadhouse.
Oh man, it's good.
I
If you
want
like
to,
that-
but never
If you
been.
like that kind of stuff, you should go to Texas Roadhouse. Yeah.
Was it Fleming's?
Go to Texas Roadhouse. Get 2020 out for that. That's the best.
The bread was okay, but that butter really. So you want volume of the solid enclosed by the two paraboloids. Z equals x squared plus y squared, and z equals 8 minus x squared minus y squared. How do you find volume?
Triple integral of 1.
What are we integrating over? Just W. Integrate over the solid that you're trying to find the volume of. So we just describe W.
Should have heard it before they were playing like music and singing.
Oh, that was not you?
But that was not new. I can hear the mic I'm sitting back here. And that's me going on like a decent amount of time.
The whole song, like, that was laughing.
And what was it? Z equals 8 minus x squared minus y squared. Oh, that's no good. So I'm clearly going to have to extend out my viewing box. For what? That's double it for, well, I guess I'm not really doubling it, am I?
You want us to see what you're doing?
Oh yeah, you can't see it now. Use your imagination.
I did.
You can expand the viewing box after the projector.
How can you not see what I'm doing? Come on. You're supposed to be able to see that. I can see it. That'll work. Oh, there's why. Really, I'm blind. So what is the solid we're finding the volume of?
That was absolutely.
A little capsule, right?
Yeah.
I call it pill shape.
Big medical combo.
'Cause I'm old and I think capsule, I think Dragon Ball. I think the Dragon Ball capsules. That's how old I am. Oh, what's a good give them there? Maybe. For now. What coordinate system do you want to use?
Yeah, it should be.
Smell food too. Describe it.
That was from. I'm gonna say 0 to.
Keep going. Keep going.
Is theta 0 to 2 pi?
Keep going.
And z is from r, or no, that's gonna be r, yes. Z is from r to, taking no, it's gonna be r squared, from r squared to r squared minus 8 or something like that. I'm trying to do that with math.
Opposite of viewpoints.
8 minus 9 squared.
Like that. face or a sad face?
I'm not sure.
I think it's a happy face.
I think it's the R, right? That's the, isn't it the R is square root of 8? Like the upper bound is square root of 8?
How'd you get it?
Looking at the bounds of things.
Yeah, so how'd you get it?
The data is going to be too high because it seems like it's going to whole like circle from the top and the bottom of our little pill capsule. The Z is what is there. I just have to switch it out to R, the proper R's. Honestly, I don't know how I got the regular, the first term correct. I don't know where that came. I don't know where that.
Oh, you're gonna be perfect in a physics lab. Don't know where it came from. That's 99.9% of physics labs. How'd that happen? I have no idea.
What it happens.
Where'd you get it? No idea.
Manners is a word.
That's physics for you.
You got the R by setting the two Z's equal to each other. And then solving for R.
I like that.
2x squared plus 2y squared equals 8. X squared plus y squared equals 4, which means it's a circle of radius 2. 0 to 2 pi, not because it's top to bottom. You go around the girth of the capsule. Remember, theta is xy plane.
I see the little flat circles.
Yeah, the curve of intersection is circle of radius 2. Right, and then, yeah, you're right. The z is pretty obvious. Bounded below by the orange and above by the blue. So just write that in cylindrical and you're good to go.
Thank you for showing me I shouldn't doubt myself.
Never doubt yourself. So what order do we want to use?
DZ, DR.
That'll work. Well, it's just dV, right? So
So would it just be DZ? Oh no, it will be RDZ because of RD. RDZ DRD.
good job catching that R. Did you? Now we have to evaluate it. Well, we can integrate with respect to theta to get 2 pi. We can also integrate with respect to z. What do you get if you do that?
4 pi total, right? Oh, we expect to see that.
R times 8 minus 2R squared. So 8R minus 2R cubed.
I'm going to factor out a 2. For r minus r cubed integral from 0 to 3. From 0 to 2.
2r squared minus a quarter r cubed from 0 to 2, which is 4.
Quarter r cubed.
Oh, r 4.
It is 4. Volume is 16 pi cubic units.
While he's working over there, what's going on?
Find the volume of this ellipsoid. X squared plus y squared plus 6z squared is equal to 100. Look down on those. Something like that. That looks good. What coordinate system do you want to use?
I'm inclined to try cylindrical.
Describe it.
Z goes from negative. Looks ugly. I'm hoping it won't if you go through it. Z goes from negative radical 6 over 6 times radical 100 minus r squared to positive radical 6 over 6 times radical 100 minus r squared.
It's too much work for me.
Okay.
Find those later.
R goes from 0 to 10. And theta goes from 0 to 2 pi. Oh man. All right.
Doing this in spherical is a B word. Because your rho is going to be dependent on phi. So it's going to be a function of phi. And it is not a nice function of phi either. It is a pretty hideous function of phi. Because that's going to wind up being what? Rho squared times the quantity of sine squared phi plus 6 cosine squared phi is equal to 100. So rho would go from plus minus 10 over the square root sine squared phi plus 6 cosine squared phi. Could write sine squared as 1 minus cosine squared, I guess, and write that as the square root of 1 plus 5 cosine squared phi. But that is still nasty. I don't even think there's a trig identity you can use to simplify that. And what are we integrating?
For volume 1, dr, dz, dr, d theta.
That?
D theta. We're trying to find the volume, right? So 1r times 1r dz, dr, d theta. Yes.
And I'll leave this as a reminder. Go find that integral. Evaluate that integral. We did the hard part together. This should be easy. We should be able to get that done by quarter after.
Would it make sense to change the order to put r on the outside so that you can keep z together until that very last integral? Does that make any sense?
It doesn't matter, right? As long as you do z before r. You can do it however you want.
Right. 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 Man, I got 200 pi over
Does
9.
that really get you? I mean, that show's still on, right?
Not in the same format.
Oh,
What is this from?
who wants to do the later?
I got 200 pi over 9. What you got?
I got 5,005.
Okay.
See your work.
If you can make any sense of it, that's not. That's it's a mess. It's a mess.
Maybe I should have this playing while you take the thing.
Why would you know?
Well, you played the death music last time. It was like the
Start playing it when there's only 10 minutes.
No.
I see where you get.
30 seconds, play the Jeopardy.
This is supposed to be
30 seconds. What is Jeopardy music?
because you have z minus negative z, which is plus.
I didn't bring it in.
You just put that there.
Yeah.
Alright.
That, I might have forgot it later, but
Maybe. Did it in a weird way.
it should. Yeah. The sequence.
What you guys the other thing?
Talking about this one? It's not death music, by the way.
What is this?
Oh, no.
Yeah, that's not new substitution.
It's a theme.
Yeah, but one is. Those are
Oh, yeah, yeah, you're absolutely right. Yeah, so that's what it's, so it's no, but I'm having a hard time. Yeah, but not because it's bad, not because you didn't write it. No, it's just because I have a hard time following stuff generally.
Yeah, we're looking at those. Follow your last two steps.
Well, it's not in the email sequence.
what did you name?
It's messed up there, so it's wrong.
Get rid of
What'd you get?
Oh,
I got four. That's
Something.
close.
Yeah, something like
I
that.
made a mistake once.
I didn't put these last substitution until like the end of the.
I tried to do it on paper.
So what values did we get?
Too many.
Too many.
Hey, how many people do you want to ask? Because that's how many values. I got. I messed up a step. Sam pointed out a mistake I made. So based on that, I'm going to say 200 pi over. Well, no, I'll just say what I got. 200 pi over 9, but it's wrong because I messed up something.
5,000 pi over.
So you need to do that in the equation.
I plugged it into a calculator because I gave up on the writing, but I got 2,000 pi radical 6 over 9, which could be right or wrong. Maybe it doesn't.
I got 4,000 pi radical 1 over 6 over 3.
It's the same as this.
It's an interesting range.
No one else got anything?
Okay, from a friend.
I don't
know
know
what-
what
I don't know what
done
friend
the
I was
calculator.
following.
I'm gonna assume it's the one.
Well, those are the same.
Yeah, I'm gonna assume the one I just.
One of those two is correct.
Yeah, I'm gonna assume it's the calculator.
Oh, rephrase that. The correct answer is up there. Which one?
Correct because it's in a more proper form.
Yeah, I think so.
Oh, then that one there. I mean left from our perspective.
They're both correct.
Right.
Yeah, that's it.
They're the same thing.
Yeah.
Right. That's very good. That's great. Yeah, that's great.
That was,
That's what I wrote down.
yeah.
Wow.
Yeah.
I'm scared and the bottom kind of freaks me out because every time I did that, I thought I was down and only to get points off for it.
What, rationalizing?
Yeah, because I didn't rationalize it. I just said, okay.
Oh, no, you don't have to rationalize.
In this class?
Yeah, you don't have to rationalize.
Okay.
Ever. In algebra, they make you, which is stupid.
No, they did not make me do that calculus one.
Well, then they're wrong. You don't have to
do have the AP
rationalize.
tests. They don't like that.
Questions on cylindrical and spherical coordinates?
Easy exam question.
I think in the quiz solutions, if I understand correctly, we use a double integral to find a volume, and on the inside we subtract the shape that bounds the top.
Yeah,
from the
just
shape.
like area between the two curves.
Yeah,
Same thing.
so
So you could do it as double integral.
right, but that is basically what you're doing when you do this, right?
When you set up as a triple.
Yeah. Wow, that's cool.
Right, just like when you set up as double, when you evaluate that
Right.
for area, when you evaluate that innermost function,
Yeah.
you're going to get calc 1 for area between two curves.
Right. That's cool. This thing of replacing the big term with z, when you have something like this.
That was just so I didn't have to keep writing it.
Yeah, but there's nothing wrong with kind of working with that until you get to
Until you need to.
right. So that's cool.
Again, it's a very common tactic, so you don't have to write out long expressions.
Right.
You just say, oh, it's this.
Right.
And then you
Yeah.
do it again when you